back in Calc 2, we talked about the center of mass in the following way. Generally, well, your instructor may be a little different than the way I did it, but generally in a Calc 2 class, I ignore the density function. I just say assume it's uniform density, and it cancels out in the process. So essentially, you say density is 1. But you got this region that you're trying to find the center of mass, and we describe it in terms of some lowest x value to some highest x value, and then we have a function describing the top. So y equals f of x will describe the top part of that, and y equals g of x describes the bottom part. And so we can talk about the area instead of calculating the mass, since you're going to be multiplying by the density function of 1, the mass and the area are essentially the same thing. So the area is just the integral from a to b of a height function, and the height function is, for each value of x between a and b, you're looking at this vertical rectangle like that, and the area of that rectangle is the top function minus the bottom function times the width, which is dx. So that's how we would calculate the area. And then to calculate the moment, let's calculate x bar. So x bar is going to be what we call the moment from the y-axis divided by the area, which we did as just this, the integral from a to b of x times f of x minus g of x dx, right? That you're saying, the f of x minus g of x is the area, and then you say, then multiply how far from the y-axis you are, right? So that area times x, and then you divide the whole thing by the area, which is just this integral from a to b of f of x minus g of x. And likewise, it's not likewise, and this is the thing that always bugged me about doing this, is that to do y bar, you're looking at mx divided by the area. So what I'm doing then is I'm saying take that rectangle and multiply by how far, take its area and multiply by how far from the y-axis it is. Well, it starts down here and it ends up there. So how far is it? This way it's so skinny, it's easy just to say, hey, it's x units away. Well, I mean, how many units away is it from the x-axis? What's the y value that I'm going to multiply by? Well, it turns out you want the y value of the middle. So to calculate the middle, you say, how do you calculate the midway between g and f? Well, add them up and divide by 2. So you got f of x plus g of x divided by 2. That's the y value you're using to then multiply by that little bit of area, f of x minus g of x dx, right? Integrate that from a to b, and then divide by the area, right? So this always disturbed me. I mean, I could get this, and then you multiply this out, and the half comes out in front, and it looks like an f squared minus g squared, and it just it just didn't feel right to me that somehow, I mean, we're calculating the same thing, x bar or y bar. Why is the formula so different looking? Well, now I can see this in a new light from the point of view of double integrals, in that x bar is the double integral over this region D of x times the little bit of area, f of x minus, it's x times the density function, right? But my density function in this problem is just 1 divided by the area. Likewise, y bar is just the y value times the density function, dA, over this region divided by the area. So it starts off with just x times the density function or y times the density function. But when you actually do these integrals, how am I going to set up this integral over this region? Well, this looks like a dy dx kind of thing. So this would be the integral from a to b, the integral from g of x to f of x dy dx. There we go. The y bar here is the same integral. I'm still dividing by the area, sorry. It's still from a to b, from g to f, but this is now y dy dx. I'm looking at, actually, thinking of another thing that we've done here. In 15.1, we talked about the notion of the average value of a function being the integral of the function divided by the area of the region you're integrating over. So this right here is actually the average x value. You're finding the average value of just the function x, and we're calling it the average x value. Likewise here, we're finding the integral of y and then dividing by the area of what we're integrating over. So this is the average value of the function y. So finding the center of mass when you have uniform density is just finding the average x value or finding the average y value. But here, so it's the one notion, average x or average y. The integrals look very similar, but when you actually do that integral, we're integrating with respect to y first. Well, integrating x with respect to y just looks like x times y, and you're evaluating y between g of x and f of x, right? There's still the integral from a to b dx. There's still the area that you're dividing by, but this looks now like the integral from a to b of x times f of x minus g of x. That's the formula we had in Calc 2. Over here, when I integrate y with respect to y, it turns into a y squared over 2. Where this was an x times y, this is now a y squared over 2, evaluated between y equals g of x and y equals f of x. I forgot to divide by the area, right? So I still have the integral from a to b of dx, and I'm still dividing by the area. But look what we have. We've got f squared divided by 2 minus g squared divided by 2, integrated from a to b dx divided by the area. Right? It looks very different, but it looks just like what we had back up here from Calc 2, that when you multiply that out, take the over 2 out, you've got an f squared, the outsides and the insides cancel out, minus g squared. That's what we have here. So these integrals look different, but they come from the same place. They come from finding the average value of x or finding the average value of y, but we're integrating with respect to y first because of the nature of the region that we have. And so the integrals look different once you've done that first step. Right? So anyway, there's Calc 2 and Calc 4 kind of tied together a little bit, the notion of average value and the center of mass. There you go.